All right, ladies and gentlemen, welcome back. So we are going to finish up our discussion about passive transport today by talking about facilitated diffusion. So keep in mind, we're talking passive transport, right? So I'm moving material from an area where it's highly concentrated to an area that it's lower in concentration. And I'm also doing this without the need for ATP. I don't need any energy to move these molecules. So we've talked about diffusion, we've talked about osmosis, which is the diffusion of water, and today we're going to talk this idea of facilitated diffusion, which is a type of passive transport, but now I'm needing the aid of proteins. So keep in mind that when we talked about the structure of your cell membrane, right, we had those fatty acid tails in the middle that provide or produce this hydrophobic region. And in order for anything to pass directly through those phospholipids, they need to be able to interact with them, which means they need to be nonpolar molecules. Oxygen, carbon dioxide, both nonpolar, so they just go straight through the membrane. Good, we're done. But there's a lot of molecules that your cells need to be able to move across that membrane that are either ionic or polar. They've got some kind of charge, and any molecule that has a charge is hydrophilic. And as a result, they can't go through that hydrophobic barrier that is those fatty acid tails. So if I'm going to move materials across that cell membrane that are hydrophilic, then the only way for that to occur is through through facilitated diffusion, passively moving through these proteins. And so these transport proteins usually come in two forms if we're talking facilitated diffusion. They can either be these channel proteins, which means they're just open and allowing things to go in and out at will as they need to, or they can be carrier proteins where we can bind things. When that solute binds to that carrier protein, it causes a conformational change in the shape and it opens to the other side, and this would go the opposite direction as well. And these tend to be more gated channels, meaning that they either are just being worked based on concentration gradients, or they can also be facilitated based on attachments of other molecules that sort of unlock the gate, if you will. We'll talk a little bit more when we get to things like your endocrine and nervous system later this year when we talk cell communication. And some of these passive transport systems don't require the energy in order to move anything, but they do require something like a hormone or a neurotransmitter to attach to that protein and sort of unlock it and open it up and allow for the passive movement of molecules. So again, these channel proteins, right, they just provide a corridor for specific molecules to go through. If you go back to the idea of osmosis, osmosis is the diffusion of water. Water's polar, which means, technically speaking, osmosis is facilitated diffusion of water. And so there are aquaporins, which are just channel proteins in the cell membrane that allow the water to go in and out and just be able to cross. Now, we could cross other things like ions as well. Just depends on what the cell needs and what the cell has in terms of proteins. But these guys are just open all the time and allow the passage to go as necessary. And then again, we talked about the carrier proteins, and these guys just changing between two configurations. Either they're open to the outside naturally, solute binds, and they open to the inside, or it could work the opposite direction as well, where they're naturally open to the inside, solute binds, they open back to the outside. And it just depends on, again, concentration gradients. Some of these are also gated channels in the sense that they need sort of a lock and key idea to be unlocked, I should say, by some other secondary molecule above and beyond just the solute. And that just kind of depends on what kind of proteins we're dealing with and the type of diffusion of those molecules that we're working with at that particular cellular level.